Welcome to clickmyproject.com. Now let me discuss about the process efficient quality analysis of MRI images using pre-processing techniques. Let me discuss about the project efficient quality analysis of MRI images using pre-processing techniques. Image enhancement has many useful advantages in many fields, mainly in medical images. Raster images are stored in a computer in the form of a grid of picture elements or pixels. These pixels contain the image's color and the brightness information. By changing the pixels, we can enhance the images using many ways. For enhancing an image using image processing techniques, pre-processing methods can be applied. Pre-processing methods uses a small neighboring group of the pixels in an input image to get a new brightness values in the output image. Such pre-processing operations are also called as filtration. For filtration, many filters were used. There are many filters we commonly use for image pre-processing, such as mean filter, median filter, Wiener filter. Wavelet transforms can also be used for image enhancement. In this paper, we use discrete wavelet transform and stationary wavelet transform and many filters such as mean filter, median filter and Wiener filter in order to compare the efficiency of the filters and the enhancement techniques that we are using. Quality analysis of images has very important applications in many fields. A method to enhance the MRI images using pre-processing techniques and wavelet transforms are proposed in this paper. The MRI images are filtered using different types of filters and the results are analyzed using PSNR values. Similarly, wavelet transforms are applied to the image and the results are compared using PSNR value. Let me discuss about the flow of the project efficient quality analysis of MRI images using pre-processing techniques. The initial step is the loading of MRI images from the database that we have given, and then the noises are added to the image. The noises are added to the image in order to reduce the quality. Noises in the image reduces the quality of the image. Different types of noises such as Gaussian noise, salt and pepper noise were available. We are using Gaussian noise to reduce the image quality. The Gaussian noise represents the statistical noise having a probability density function equal to that of the normal distribution. Then we are going to filter the noised image using different types of filters and using different type of enhancement wavelet based enhancement methods available, and we are going to compare these results. This is the main process of the project. So first we are using mean filter to filter the input image, to filter the noises from the input image. The mean filter considers each pixel in the image in turn and looks at its neighboring pixels to decide whether or not it is a representative of its surroundings. The mean values are calculated for the surrounding pixels. The mean filter replaces the defected pixel with the mean value. Next, we are going to filter the noised image using median filter. The median filter considers each pixel in the image in turn and looks at its nearby neighboring pixels in order to decide whether or not it is a representative of its surroundings. Instead of simply replacing the pixel values with the mean of the neighboring pixels, it replaces it with the median of those values. The median is calculated by first sorting all the pixels of the values from the surrounding neighborhoods into a numerical order and then replacing the pixels being considered with the middle pixel value. Then we are filter the noise in images using the Wiener filter. Wiener filter is used to produce an estimate of a desired or target random process by linear time invariant filtering and observed noise process. The Wiener filter minimizes the mean square error between the estimated random process and the desired process. It is assumed to have the knowledge of the spectral properties of the original signal and the noise. It seeks the linear time invariant filter whose output would come as close to the original signal. Then we are going to filter the enhance the noise image using discrete wavelet transform. Discrete wavelet transform splits the images into four subbands: low, high, and high. The readability of an image is calculated by passing it through a series of filters. First, the samples are passed through a low-pass filter with impulse response resulting in the convolution of the two. The signal is also decomposed simultaneously using a high-pass filter, the output giving the detail coefficients and the approximation coefficients. The useful information were present in the low component. Finally, inverse readability is done in order to get the enhanced image. Then we are going to enhance the image using stationary wavelet transform. Stationary wavelet transform and discrete wavelet transform, the working are the same, but the type of filters that we are using in the discrete wavelet transform and the stationary wavelet transform differences. The stationary wavelet transform also splits the images into subbands based on the filters design. Then we are going to enhance the image using DWT and SWT. Here we are going to combine the low components of the DWT and the low components of the SWT so that we will get an enhanced image. Finally, we are going to compare all the results using PSNR value, that is calculator. If the PSNR value is high, means the resulting image is enhanced. Like that, we will get an enhanced image through this process. Let me discuss about the execution of the process. Efficient quality analysis of MRI images using pre-processing techniques. In this process, we are going to enhance the input MRI image using different filters and enhancing them using some wavelet coefficients. First, in order to run the code, please select the preprocessing.m file which is present in the source code folder. When you right click it, you will get these tabs. Click on run file. You will get this sky window. So this will contains all the user interfaces needed to run the code. First, select input image in order to choose the image that you want to run. Then add noise to the input image so that the PSNR value of the input image is much reduced and the image is degraded. When we are going to filter the noise added image using the following filters. First, we are using mean filter. The mean filter calculates the mean value of the neighboring pixels and replaces the noisy locations in the image. Similarly, we are then applying median filter. The median filter filters the image by replacing the median value for the noise added pixel values so that the image is enhanced. Then we are using Wiener filter. The Wiener filter combines both the mean and the median filter values. And then we are enhancing the image using wavelet transforms. First, we are going to enhance the image using DWT, that is discrete wavelet transform. And then we are going to enhance the image using stationary wavelet transform. And finally, we are combining DWT and SWT in order to enhance the image. First, we are applying DWT. The DWT will decompose the input image into the 4 level coefficients. The initial low coefficient only contains the useful image that is needed for us. Then the remaining coefficients contains the values of the different filtered values. The low coefficient contains the value that is filtered using the low filter, and then this coefficient contains the values using high-low, then low-high, and then finally high-high. Similarly, when we are applying inverse transform, these 4 coefficients were again combined so that we will get the enhanced image. Then finally, we are combining these using applying inverse DWT so that we will get the inverse DWT using the DWT. Then finally, we are applying the stationary wavelet transform to the image. The stationary wavelet transform will decompose the image as similar to the discrete wavelet transform. We are getting the 4 coefficients, and then finally we are combining these coefficients in order to get the enhanced image. So the enhanced image contains the important information which is present in the MRI brain image. Then we are combining the result of the DWT and SWT, that is the low components of the DWT and then high components of the SWT, and then again we are fusing so that we get enhanced image when compared to both DWT and SWT, and then we are finally measuring the performance of the all the filters that we are using. First, initially we are calculating the PSNR values for all the filters. First, we are calculating PSNR value for the main filter, and then for median filter, as you can see, the value for the mean filter is increased when compared to the value for the median filter. Then finally we are applying Wiener filter. The PSNR value is further increased. The increase of PSNR value represents that the images were enhanced. Then we are calculating the PSNR value for DWT and then for SWT, and then for combining DWT and SWT we are getting the overall PSNR value. Thus we are enhancing the input MRI images using several pre-processing techniques, that is mean filter, median filter, Wiener filter, DWT, SWT, and combining DWT and SWT. Finally, we are getting the enhanced MRI images which contains all the useful informations in them. Thank you.